So today we're going to work on graphing parabolas in standard form. So as you can see right here across the top, one of the major goals of our mathematical curriculum is to help you recognize and understand natural and recurring patterns. There's lots of good patterns that go along with parabolas. And catching on to those patterns is the way to make this easy, or I should say easier. Graphing parabolas can be done one of two ways. First, the easy way, try to recognize and understand the patterns, and if that doesn't work, you can always grind your way out. Working hard and making charts that require you to perform endless calculations, right? So let's try to work smart. What are some of the things we need to be able to do? We need to be able to identify the vertex, locate the axis of symmetry. Those two things happen simultaneously almost. Then we're going to find 2 points on one side of the vertex, reflect them across the axis of symmetry. We should know whether or not the parabola opens up or down. We should be able to identify the y-intercept very quickly in standard form. We should decide if the parabola is narrower or wider than the parent function, and then we should be able to draw it. All right, so as I look at this parabola here, it's opening down, so I know that my a value is negative, okay? Now, I can't really say much with this picture as far as the width is concerned, so I'm not going to say whether or not a is a fractional value or a value that's greater than 1, but I do know that it's negative. And this little green dot right here, that's our vertex. This blue line, this dotted line, is our axis of symmetry. That axis of symmetry has an equation because it's a vertical line, so it's x equals some value or a constant a, and maybe a is not the best numbered letter to use right there because I don't want you to confuse that with a, but let's just say that it's a number. X is equal to a number, and in this particular situation, x is equal to 2. But in general, it's always x is equal to something, and that x is also the x value of our vertex, right? So the vertex is always the opposite of b over 2a. So when we're looking at a standard form of a parabola, you're talking about f of x equals ax squared plus bx plus c. That's the standard form. And so I need to identify who a is, who b is, and who c is, whether they're explicitly written or implicit. I need to be able to identify them so that I can figure out what my vertex is and go from there. Moving on. How do you identify the vertex? Well, you can look for certain characteristics. If you just see f of x equals ax squared, so for example 1, say f of x is equal to 5x squared, then what we're trying to tell you is that b is equal to 0, and a is equal to 5, c is equal to 0. But most importantly, b is equal to 0. So the x value of my vertex, and the axis of symmetry is opposite of b all over 2a, is the opposite of 0 over 2 times 5, which is 0. You can guess now that I'm at school still. All right, now, moving on to example number 2. Where's the vertex? The vertex is always at 0 comma some value of c. So why is it 0 there? Well, again, there's no b value, so the opposite of b over 2a is still going to be 0 divided by something, which is going to be 0. So that's why this value is 0, and that's why this value is 0. Otherwise, it's going to be some numerical value that I can calculate by processing the opposite of b over 2a. Then we're going to use that information to start building that box, and I'm always going to put my vertex in this first point right here, all right? Of course, I'm going to continue to build the box and give myself 5 points. But this is going to be my x-coordinate of my vertex, and that's going to be the y-coordinate of my vertex. Then, we're going to choose some other points. How do you choose the 2 points? Well, for me, I choose 2 values on one side of the vertex. So, say the vertex was at negative 5, 8. Then I would use negative 4 and negative 3. In ascending order, then, that's where those would go, and this would be the negative 5. And then, of course, going the other way, I would be at negative 6 and negative 7. Now, what I suggest is substitute those x values. The negative 4 and the negative 3. Substitute those into your function, get values of y, and then reflect them across the x-axis, meaning across the y-axis, meaning these guys are going to be the same y values if you do your arithmetic correctly. So at first, I'd recommend substituting off 4. Then on down the road, you can start to get a little bit more slick. Now, if you have a function like this, where you see that ugly fraction in the front, then choose values that cancel out 3 in the denominator, like multiples of 3. Use values like 3, 9, 12, negative 3, negative 9, negative 12. Those are values that would need to go across the top here so that they would play nicely and you get nice integer values. Otherwise, if you always just go by ones on both sides, you're probably going to get some fractional values for y, and you're going to be grumpy and have a hard time graphing it. So let's get into some practice and give it a shot. First things first. I see my f of x is equal to t squared plus 10t plus 25, so a is 1, b is 10, and c is 25. All right, so the first thing I want to do is x is equal to the opposite of b all over 2a is equal to the opposite of 10 all over 2 times 1, which is negative 10 over 2, negative 5. That negative 5 goes right here. Now, since there are no ugly fractions over here, I'm just going to say count by 1 unit, negative 5, negative 4, negative 3 on that side, negative 6, negative 7 on this side. And I'm going to now start substituting in. The first one, f of negative 5 is equal to negative 5 squared plus 10 times negative 5 plus 25. And when you're done, you should get a value of 0. So f of negative 5 equals 0. So 0 goes here. Now, I need to evaluate the same function for f of negative 4 and f of negative 3. Now, I've done this on separate paper. You should do this on your own. I get, for f of negative 4, I get a value of 1, and for f of negative 3, I get a value of 4. So I'm going to put 1 and 4 here. Now, if I've done the math correctly, these values should be the same, and these values for our y values should be the same, because negative 7 and negative 3 are both 2 units away from negative 5. So since they're equidistant from the vertex on either side, their y values should carry the same value. So I can confidently place 4 there and 1 there. A good place to go would be to go to y equals in your calculator, put the function in. I know you don't have a t, but you could just use x and say x squared plus 10x plus 25, and then second graph, get a table of values, and go find negative 5. It lines up with 0. And as you go to negative 6, you're going to see that maps to 1, and negative 7 maps to 4. All you're left to do now is just plot your points. Take a moment and sketch a quick graph. Now, as you see, it's tough for me to graph on this program, but here's my parabola. Here are my points. This parabola is opening up, and my a was negative, so it's supposed to. I've placed my line of symmetry, and notice these points are the same distance away from the axis of symmetry. So that's it. Identify your a, b, and c, get this x-coordinate, place it right here, pick some wisely chosen x values that go along with it, evaluate for the y values, plot your points, draw your graph on your axis of symmetry, and be done with it. It's nice to take a look and say, does my picture actually match up with what I thought? It seems to be reasonable. I guess the last point of reference on the way out the door here is this c value of 25, that's my y-intercept. That's going to be like way up here. And all I'm saying is, as this graph comes up, is it going to go through 25 for a y-intercept? It seems plausible, so I feel pretty comfortable with this. Let's move on. This next problem that I'm going to do for you is a problem that's on the next handout that you're going to work on in class. So if you're watching this video, you already got one of the tough problems done for you. First thing I want to do is just identify my coefficients. So I got my negative 3/2. B is not there, so 0 times x would be the only way that would happen, right? So B is 0, because it's missing, and C is 3. Like we've done before, I want to identify that axis of symmetry and the x-coordinate of my vertex. It's at the opposite of B over 2 times A, which is the opposite of 0, all over 2 times negative 3/2. Now, just for ha-has, I know this is going to be 0, but that was going to be 0 over negative 3, which is still 0. But I wanted to show you how multiplying that fraction on the bottom wasn't really going to be that big of a deal. But we already know from the previous screen that if you have y equals ax squared plus or minus c, that our vertex is at 0, comma, c, which also happens to be our y-intercept. So let's go ahead and build our box. Okay, now I'm going to put that x value right here. That center spot is located for my vertex purposes. That's my x-coordinate. When I substitute x into this function, I get y is equal to negative 3/2 times 0 squared plus 3. What happens to all that? I get 3. So 3 goes here. Now, let's choose some wise options for x. I know I got lucky with the value of y for the vertex was a integer value. There's nothing I can do with that if it's a decimal. It is what it is. But as I move, or fractional value for y, right? If y was like 1/4 or 0.25, either way, there's nothing I could do about it. It's the vertex. I need that point. But the other x values that I'm going to choose here are exactly that, my choice. So I'm going to try to pick numbers that work with 3/2 well, either way. So I'm going to pick even numbers. I'm going to go by 2's, 2 and 4, negative 2, negative 4. And then I'm going to substitute those in. So I'm going to get y is equal to negative 3/2 times 2 squared plus 3, which is equal to negative 3/2 times 4 plus 3. So the 2 cancels out the 4, makes that a 2. 3 times 2 is 6, but that's a negative 6 plus 3 is negative 3. So negative 2, or positive 2 goes with negative 3, and then these values are the same, so that's negative 3. I'm going to do the same for 4, and I'm going to get negative 21, and for negative 4 I'm going to get negative 21 as well, and then I'm just going to sketch a quick graph. Since I got such huge negative values, the only positive value I have is 0, 3, right? I'm just going to say that this point right here is 0, 3, and then 2, negative 3 is going to be right here, and negative 2, negative 3 is right there, and 4, negative 21 is way down here, and way down here. Now, is that legit? Good enough for us now. So let me just see if I could kind of slide this up a little bit. Give myself a little room to draw my parabola through. And here's my axis of symmetry right on the y-axis. And that's it. When I go back to this, what was supposed to happen? I was supposed to have a graph that opened down. This is 1.5, so it's not supposed to be wider. It's supposed to be narrower. A little off scale, so it's not the greatest looking graph. And shift up 3. Did it do all those things? Yeah. How are we looking? Pretty good. That's it. Persevere. That's the word of the day. See you later.